Alright guys, welcome to our intro lesson on what's called nomenclature. And you guys, that's just a fancy word for a naming system, you guys. And this is what we need to be able to do. For example, this is the chemical formula. We'd also want to be able to give the appropriate name. I think a lot of you guys could look at that. Obviously, that should look a little familiar to you guys. We could call it salt, but the appropriate name would be sodium chloride. So we should be able to go from the formula to the name. This is what we're going to be able to learn to do. I'm starting with some ones that maybe are a little bit more familiar to us. Maybe this one's not so much familiar to you, but it is probably in your refrigerator at home. Some of you guys would have it there or in a cabinet. A lot of you guys recognize Na is sodium. You're maybe wondering what that is. Sodium, that is sodium bicarbonate. We know it as baking soda. Carbon dioxide, look, we are going to be able, as a result of this unit, go from the formula to the name, but we should also be able to go from the name to the formula. Carbon dioxide, what would be the formula? Think about it, guys. That would be CO2. This one's a little bit more difficult, but I wouldn't expect you guys to know it at this point. This is just kind of letting you guys know what it is we're going to be looking forward to here in the next week or so. And then the accompanying formula for this would be, a lot of you guys knew potassium was K. I didn't expect you guys to know permanganate, that's MnO4. So we're going to introduce this term valence. You guys, valence is much like a charge on an atom oftentimes, but more specifically, it's the combining capacity relative to hydrogen. You can look at it as the number of bonds an atom or group of atom needs in order to be complete. Okay? So, for example, if we had water, we could then determine what is the valence of oxygen and water. Well, if valence is the combining capacity relative to hydrogen, you guys can see oxygen binds to 2 hydrogen atoms, so wouldn't the valence of oxygen have a valence of 2? Okay? Look at HCl, combining capacity relative to hydrogen. Well, look, it's a 1-to-1 ratio, so wouldn't chlorine have a valence of 1? And then look at aluminum chloride. You're like, well, wait a minute. If I'm trying to figure it out for aluminum, I don't see hydrogens, but I did know that chlorine has a valence of 1. It looks like there's probably 3 chlorine atoms bound to the aluminum, so wouldn't you maybe anticipate or predict aluminum has a valence of 3? And then lastly, we've got magnesium oxide. Once again, it's not really bound to a hydrogen, but I see oxygen has a valence of 2. We see it's a 1-to-1 ratio, so if oxygen has a valence of 2, might you predict that magnesium would have a valence of 2? So here's something that you guys are going to be expected to look at. There's what's called a valence sheet that is found in the material section in your Google Classroom. You guys are going to have to reference this. I highly encourage you guys to highly encourage you guys to print this out and have it available to you guys. I'm going to show you guys how to read it first of all. So first of all, you guys look, the first column here all the way down, that's called monovalent, mono meaning 1. So these all have a valence of 1. Notice this column here is divalent. These all have a valence of 2. And then trivalent all have a valence of 3. You might think of these typically forming 3 bonds, these typically forming 2 bonds, these typically forming 1 bond. That's a good way to look at it. Then you guys will notice here it says metals. Well, metals have what's called a positive valence. You guys remember that's like kind of equivalent to, remember metals have a tendency to lose electrons. So these all have positive valence values. So more specifically in this quadrant right here, these all have a valence of +1. These all have a valence of +2, and these all have a valence of +3. Okay? And then look at down here, we have nonmetals and what are called polyatomic ions. Polyatomic ions are groups of atoms together. You guys will see, like for example, these are nonmetals, but now look at these atoms that typically come together. Those are called polyatomic ions. They have what they have a negative valence, meaning they tend to gain electrons, right? So more specifically, the ones in this quadrant here have a -1 valence. These ones have a -2 valence, and this is -3. So hopefully you guys know how to read this. Column 1, 2, 3. These are positive valences, these are negative valences. So there's a few things that we're going to note. You guys, in fact, this is why I wanted you guys to print it out so you guys can make some corrections to the valence sheet. I'm not going to expect you guys to know mercury. That just gets a little kind of confusing, so you guys would cross that out. Hydrogen sulfate can also be called bisulfate. So sometimes we use older terminology that was used for a substance before we came up with a more systematic approach that we have with nomenclature. So sometimes they use the older term, which would be bisulfate. Another one here, hydrogen carbonate, could also be called bicarbonate. You guys remember on that first slide we had sodium bicarbonate? So HCl3 would be called hydrogen carbonate or bicarbonate. I know this is kind of hard to see down here. This is acetate. I think it's showing correctly on the sheet. Remember, it's called the valence sheet found in the material section. This is CH3COO. Hopefully that shows correctly on your valence sheet. I'm not going to have you guys remember peroxides. Now normally guys, I'd have you guys memorize this. I'm probably going to be a little more lax with the distance learning. I'm trying to think. Oh, and also monohydrogen phosphate, that could also be called biphosphate, right? You guys see whenever there's a hydrogen in front, like hydrogen carbonate, hydrogen phosphate, hydrogen sulfate could also be called bi. Okay. So, oh, another one. You guys see hydroxyl? Whenever it's in the name, we usually don't use the term hydroxyl. We usually cross out the N, and we usually call it hydroxide. It's called hydroxide. So make a note of that. And this was chlorates. So just a few changes. So you guys, now all the notes or the slides we're going to look at are going to give us some more detail about this valence sheet. So on the valence sheet, you guys should have noticed the metals. You guys remember those are on the top. They have a positive valence. However, what else you will see on the top of that sheet right here, I don't want to go back to it. You'll also have hydrogen. Hydrogen is actually, remember, it's a non-metal, but for purposes of naming, we give it a positive valence. And then there's also NH4 here. NH4 ammonium is also there. That's a positive. So those are two exceptions, meaning those are two that really technically aren't metals, but for purposes of valences and naming, we assign it a positive valence. Now you guys, it's not as if you have to memorize that whole sheet. A lot of these things you can get from the periodic table. For example, all of the metals in column number 1, you guys remember, you all expect those, they have one valence electron, you expect them to lose one valence electron and acquire a +1 charge. They have what's called a +1 valence. And you guys can imagine, right, the metals, the alkaline earth metals, 2 valence electrons tend to lose and acquire a +2 charge. They have a +2 valence. So those ones you don't have to memorize. You would just know based on their location in the periodic table. Now, unfortunately, the ones in the middle, these are called the transition metals like iron, cobalt, zinc, copper, all the metals that we're kind of familiar with. Those ones you're just going to have to learn them. Meaning you got to look at your valence sheet. In fact, I highly recommend you guys make flashcards, and on one, for each of those substances, and on one side put the name, and then on the back put the formula and the valence value, and then just kind of teach yourself that. So, guys, to add a little bit extra complexity, some metals have more than one valence because depending on what those metals are bound to, they might lose 2 electrons when bound to something, or they might lose 1 electron, for example. So for an example, one of those metals that has more than one valence is iron. You guys will notice when you guys look on your valence sheet, iron is right here as a +2, and it's also right here as a +3. It's iron 2, iron 3, we use the Roman numeral to indicate that. There's also copper. Copper can have a +1 valence. Copper is right here in the first column, and it's also in the second column. It can have a +1 or a +2 valence depending on what it's bound to. And then there's 2 other ones that I want you guys to be familiar with. The other 2 are tin and lead. Those of you guys who are familiar with Roman numerals, obviously this is easy. These are 2. But an IV, if you guys are familiar with Roman numerals, you should know that means a 4. So tin can have a +2 valence or a +4 valence. Lead can have a +2 valence or a +4 valence. So those are the 4 metals in particular I want you guys to remember that have more than one valence. Iron, copper, and then tin and lead. Okay. She says, I'm a vegetarian. I think meat is murder. Oh, I agree. He said, give me a steak. Oh, and make sure the cow committed suicide. Right, he didn't want one of those cows, not the ones that kill. It's kind of messed up. Okay. Anyways, nonmetals. You guys should remember from your valence sheet, nonmetals are on the bottom. They have a negative valence. And you guys, once again, it's not like you have to memorize the entire valence sheet. There's some you should already know. You guys see the second to last column, you guys remember the halogens next to the noble gases? They tend to gain 1 electron. They have a -1 valence. The third to last, where oxygen starts, you can also call it the oxygen group. They have a -2 valence. They tend to gain 2 electrons. They acquire a -2 valence. And then the fourth to last would even be start from nitrogen. Here, I don't know if you guys can see that. You guys should have your periodic table out. It's good to have it when we're doing these video lessons so you guys can see it a little more readily. Those would have a -3 valence. So once again, you don't have to memorize those. You just have to remember that from the position of the periodic table. So there's also, here's what's new. So you guys, we are familiar with metals and nonmetals. Let me just show you guys here so you guys can see what we're talking about. So polyatomic ions are groups of atoms that tend to stay together. So for example, down here, these are nonmetals and polyatomic ions. You have to be able to know the difference. Notice, obviously, that's nonmetal. These are all nonmetals, right? They're just one type of atom. But now look at NO3. That's more than one type of atom. That's what polyatomic means, and it's ion because it has a charge. These are all the polyatomic ions. Check them out, all polyatomic ions. Polyatomic ions, oh, these are nonmetals. You guys see, they just have one type of atom. Polyatomic ions, non-metal, polyatomic ion, non-metal. So that's what we're saying, differentiate between those, because you guys are going to use different rules when it comes to naming it. You guys, this is all introduction. We haven't even really put, really what we're going to get together is we're going to take these items on a valence sheet and put them together in what's called a binary compound, getting two things from the valence sheet, and then that would make it what's called a binary compound, and then you should be able to write the formula and indicate the name. This is all just kind of getting you guys familiar with the valence sheet, so make sure you guys, once again, you print it out. I would suggest make flashcards, kind of get used to what the name is, what the formula is, along with the valence. So polyatomic ions, groups of different atoms that function as a group, they kind of stay together as a group. These would be characteristic polyatomic ions. You look on your valence sheet, these are in the second column, they have a -2 valence. And then these are in the first column, they have a -1 valence. Once again, that you're just gonna have to just study your valence sheet until you know it kind of sits in your brain. So you guys notice kind of the way they name things now. They try to have a little, somewhat of a pattern to help you. Notice this one has 4 oxygens, this has 3. Typically, your polyatomic ions are going to have oxygens in it. That's a typical polyatomic ion. Typically, the ones that have the most oxygens end in ate, and the ones that have the least oxygens ends in ite. You guys see where the sulf comes from, the fact that it's sulfur. So SO4 is sulfate, SO3 is sulfite. Using the same rationale without looking at the valence sheet, you could probably try to predict what these are called. What do you guys think NO3 would be called? What do you think? Wouldn't that be called nitrate? And what about NO2 with less oxygens? Nitrite. So it's nitrate, nitrite. Now you guys, they don't all follow that pattern. You would think based on this might be chromate and chromite. I could see that if we use the same kind of rationale. But if you look on your valence sheet, CrO4 is called chromate, and these both have a -2 valence. But this one right here, this polyatomic ion, it's actually called dichromate. It comes from the fact that there's 2 chromiums. So there's some that don't really fit a pattern. You just have to look at your valence sheet, study it, memorize it, so that way you guys would know that. Okay. And then here, you guys, we talked about these briefly. You look on your valence sheet, these are in the, the name is called hydrogen sulfate, and then this one is called hydrogen carbonate. But then you guys remember, we can also call it bisulfate, you know, see with the hydrogen on front, and then the hydrogen on front here, instead of hydrogen carbonate, you could call it bicarbonate. Kind of like, you remember your baking soda was sodium bicarbonate, it was NaHCO3. So, you guys, ultimately where we're going is, just as giving you guys what we're looking forward to, we're pretty much done here. We're going to be looking at binary compounds, which are a combination of 2 things. We take 2 things from the valence sheet. And you guys think about it, even right now, what 2 things could we take from the valence sheet? We could take a what combined with a what, and a what combined with a what. There's actually 4 different ones, and here they are. So this is what we're going to be going over here. Oh, you know what? I am going to be going over, yeah, I think this will be it. You can have a metal-non-metal combination. You could have a metal polyatomic ion combination. You can have an acid, which is a combination of 2 things. I won't talk about what that is yet. Or you can have 2 nonmetals together. The reason why we have these in different categories is because there's different rules we use in order to name those compounds. And I think we are done. Yes, we are. All right, guys, until next time.